Chapter 9, Thermochemistry, Exercise 9.65. Two substances A and B initially at different temperatures come into contact and reach thermal equilibrium. That means the final temperature of A is equal to the final temperature of B. The mass and initial temperature of A are given. The mass and initial temperature of B are also given. The final temperature is given. So what's missing? If the specific heat capacity of B is 1.17, what's the specific heat capacity of A? So again, we're going to use this equation, Q sub A plus Q sub B equals 0. We can use this equation to solve the problem. And also, we can simply use Q sub A equals negative Q sub B. These two equations are the same. And then we plug in numbers. It seems we have enough information to get Q sub B. We need the mass of B. We need this specific heat capacity of B. And also we need the temperature of B. They're all given up there. So let's find the information here. The mass of B is 25.9. The specific heat capacity is this. The temperature change for B, always final minus initial. Final is 46.6. The initial of B, 52.3. Alright, so this is Q sub B. As you can see, the temperature change is negative. Alright, this temperature change is negative. Q sub A. Q sub A, let's get the mass of A. The specific heat capacity of A is unknown. I'm going to use X here. I'm going to solve for X. What's the temperature change? The temperature change is the final temperature of A, which is also 46.6, and the initial temperature of A is 20.5. Now you can see delta T of A is positive, delta T of B is negative. We'll just solve this equation. Alright, how do we do this? So X is simply this part divided by this number divided by this number. So we'll just do this. I'll get rid of this. Both sides divide by 6.01. Okay, it's better to move this up to be clear, and I'll move this to the right hand side as well. Okay, now that's it. The value of X is 1.10, and X is the specific heat capacity of A. By the way, I made sure the units are used consistently. This is in grams, this is in grams. This is joule over gram and degree Celsius. This is in degrees Celsius. This is also in degrees Celsius. Alright, similar calculations. If you look at this calculation on top, they have the mass of water, the mass of B, C sub S of B, temperature change of B divided by the mass of A and temperature change of A.